Okay, let's start our webinar. Uh, Hello, everybody. Welcome to PassEquip webinar. Your presenters of this webinar are Andrei Krasnokutsky, head of our stress department, and I am Leonid Korelstein, PASS VP on Research and Development and World Market. Andrei asked me to present you the general review of our PassEquip software and some new features. And he will focus on demonstration. He would want to demonstrate you some interesting examples. So our agenda for today is first some general presentation about what is PaaS software in general and detailed review of PassEquip features. And I will also note improvements that appeared in the latest version. And then I will talk somewhat about what you can expect and what we are working on for the coming version. And then to go to PassEquip demonstration and then answer to your question and answers. But you can put your questions already, but please put them not in the chat, but in the question and answers section, so that all your questions and our answers would be recorded. And the seminar is recorded, and the video will be available for all registered participants. So let's talk about our PaaS software. What is PaaS software? PaaS suite is a piping and equipment analysis and sizing software suite. It covers all main aspects of piping and equipment analysis and include four main components, four main programs. These components are PaaS hydro system for piping system fluid flow and heat exchange analysis and sizing, PaaS StarPro for piping system stress analysis, PaaSEquip for pressure vessels and other equipment type stress analysis. This is what we will talk about today. And the fourth component is nozzle FEM. And nozzle FEM software can be used as a separate software and in combination with both PaaSEquip and PaaS StarPro. And it provides FEM analysis for nozzle pump, shell junctions, and some other non-standard elements, both for piping and equipment. And all this software also comes with integration tools with different CAD systems. And behind all this software is more than 50 years of non-stop development, starting from mainframes and permanent improvement. So when this software is used in different industries, but our main focus is for process plant, piping industries, also in district heating, transfer piping and equipment, in oil and gas, of course, for gathering, distribution, storage facilities, piping network equipment, mechanical and in-house piping, and of course, PaaSEquip is used by pressure vessel manufacturers, heat exchanger manufacturers, and other equipment. So we position our software solution as tools for every piping and equipment engineer and designer, because it combines very powerful engine, analysis engine, based on the most advanced model methods, algorithms, and libraries both developed ourselves and licensed from third parties, from our partners. And in the same time, we put it into the GUI and under the cover of a very user-friendly interface and integration with your workflow and provide all kind of help system, training, online, offline, so the new user could start in days rather than months. This is something about past geography. We have customers in all industrial countries. And now let's talk about the software of our webinar focus. It's PassEquip. What is PassEquip? PassEquip is the software for analysis of pressure vessels and other types of equipment. What kind of analysis? Static analysis, first of all, of course, but also load cycle fatigue analysis, bottleneck analysis, seismic analysis, and MDMT calculation. The analysis is made by formulas as prescribed by different codes, mainly, but also in some case, 1D FEM model is used. And this software is accompanied by pass nozzle FEM for full-scale FEM analysis of nozzle shell junctions and other non-standard elements. And in some rare cases, when there's very complex and we cannot address this inside our software, we also have a feature for automatically preparing a model for analysis in ANSYS, for frame covers for tanks, for example, for frame roofs for tanks. What kind of equipment we address? Horizontal vessels and vertical vessels. The difference is just in support types, columns, heat exchangers of two main types, shell and tube and air-cooled, and vertical tanks. Here are some examples of our users in different industries such as oil refining, chemical, petrochemical, oil and gas, thermal power, and others. And you see some famous names here, like ThyssenKrupp, Technical Reunidas, many Italian companies, German companies, and so on, Korean company. Okay, two examples from users, just to demonstrate how it is used. This is Oil Team International FZE, equipment from Component Mobile Separation Unit. And here you see models in PassEquip and real equipment. And here you see another example, models in PassEquip and model in CAD system from Phi or Thyssen. Okay, let's go to features of PassEquip. So what codes were coded? First of all, of course, such international widely used codes as ISME Section 8, Division 1 and Division 2, AN code for pressure vessels. For nozzles, we use WRC for analysis by formulas. And for tanks, we implement API 650. And also, of course, different national codes, for example, all Russian codes, not only codes, but also for nuclear power. It was extended in latest version, by the way, and we had also boiler code. But also we use, of course, different national and international codes for different kind of loads. And for some specific elements, we use some special codes or methods which are widely used and became RAGAP methods or recommended by experts. We also have a large database which include different materials and its properties, steels, from ICME standards, EN standards, Chinese standards, Russian standards, and others, and database of standard sizes of different vessel elements like shells, heat, flange, saddle supports, and other type of supports, nozzles, and of course beam or steel element profiles or sections for support structure. For nozzle shell junctions, we, as I already told, use WRC, but we also have integration with pass nozzle FM. So any shell junction connection, shell nozzle junction, you can export and immediately open in pass nozzle FM and calculate. But I guess Andrei will show. Okay, what kind of loads? All kind of loads that you have to apply to pressure vessels. Pressure, internal and external, and of course we address buckling analysis for external pressure. Weight of materials, fluids, and thermal insulation. Different temperature effects like thermal deformation, and it's important. Nozzle forcing moments, which you can calculate from piping stress analysis, for example, and apply. And wind loads, according a lot of different standards, snow loads, for example, on the platforms and on the roofs of tanks. Seismic and inertial loads from different codes. And we also can do buried vessels. And for these underground vessels, we, of course, take into account interaction with soil weight, and interaction with concrete support structure, of course. And you can also apply some additional external and weight loads. And you can do multiple load cases. You can define several load cases like operation, transportation, testing, and so on, and do this calculation simultaneously for all load cases. So input data is smart, so the software checked all the data and give you errors or warning message that something is wrong and suspicion. And we also have on-the-fly analysis for required thickness or MAWP. And when we defined data from elements in the same window, you immediately see everything. So this is example of general data screen where you can define load cases, what is fluid, gas, or liquid, and how you would like to take it into account, and also what code you want to apply for testing and so on. By the way, I forgot to mention that, okay, we have different codes, but sometimes it's the situation that you have some element for which your code by default is not applied. So you can define different codes to apply for different elements in the model. And sometimes it's very useful. So for wind loads, we have a list of different national and international codes, including US, Canada, Mexico, India, Russia, and we just, in this version, we add China and Uzbekistan. And because they ask, our partners and our customers ask us, so this is our principle, how we're working. You ask us for some improvements, and we do it. So if you want something, please do it, and do it right now. Put it in the question and answers. For seismic loads, also we have the list of different implemented norms like Canada, US, India, Azerbaijan, and this version we again added China and Uzbekistan codes. For underground vessel, we take into account interaction with the soil, and we also calculate floating up, possible floating up. And this is already available in this version, but we have plans to improve it in the next version. Of course, material databases, and you can see everything, all properties, select materials according your standard. But you can also define your own materials. There is a user section, user materials, in the database, and you can edit or you can copy some standard material to this section and start to change it and save and use it for your calculations. Some smart features that we have. First of all, we try to do everything for you. So you don't need to worry and to bother with some intermediate calculations. The software tries to do everything itself. So it calculates all weights, all lengths, all properties or mechanical properties of different elements, liquid volume, fill ratio, and hydrostatic pressure and how it's changed for the versus height versus level. And we also have dependency between elements. What it means that if element is connected, the program follow up it. And if you change some parameters, diameter, for example, of shell, it automatically will change the diameter of connected hits. You can select different units, metric, imperial, or your custom units, and customize them. And you can have some non-standard things like a horizontal vessel on more than 2 saddle supports, for example, like this one. And here we're using some 1D model, some beam model with beams of changing cross-section properties, and we can calculate all forces, moments, and open them and put them into this kind of diagrams. And we have a very powerful model visualization. Because it is based on some 3D solid kernel. And we can visualize our model as you like, solid, wireframe, transparent view, rotate it, zoom in, zoom out, and so on. And with a very high level of detailing. And so it's what you see is what you really have in your model. And because we have these powerful kernel libraries, we can export our models in different formats like IGS, STEP, ACIS, or Parasolid, and open it in different CAD systems, like this, for example, in AutoCAD, or for example, this is a heat exchanger model, which was created in PASEQUIP, but then exported to SolidWorks with all details. And you can start even with PASEQUIP and then continue your work in your CAD environment and produce some detailed drawing on the base of such models. And of course, we have also export to Nozzle FM. Okay. Another very interesting, maybe unique feature of our software is composite, complex equipment. So this is equipment which consists of several connected standard equipment types like heat exchangers, for example. This is example of double heat exchangers, and we have special element in the model like links and connection points. So you can define the different type of link, like a rigid link, some type of beam, and so on. We also support non-circular or rectangular, for example, cross-section equipment like this one, with arrows of holes and so on. Let's also look at some specific features for different types of equipment. For columns, we have calculation of vibration frequency, lowest vibration frequency mode, and also high harmonic. And of course, we take into account forces and wind loads and seismic loads, and stress and stability of different elements. And supports, of course, both support kits with automatic calculation of most unsafe cross-section of supporting shell. And also we calculate loads on basement and support structure. And with these loads, you can continue this calculation and calculate this basement support structure in other special software. We also have ropes for connection with columns. You can model this ropes connection, both absolute, flexible link rope, and so on. For heat exchangers, we have different types of shell and tube exchangers, and also air cooling exchangers. And we calculate all parts of these heat exchangers, but we have especially powerful tool for tube shape modeling. We have tube shape designer, which allows you to define any kind of complex tube shape geometry. And for tank, we have API 650 code with automatic weight measurement and stress and stability analysis of walls. Of course, you can define different thickness on different level. So the construction of the wall and wind, snow, and seismic loads. And you can calculate loads in basement, and you can calculate roofs and frame roofs. And here is how you made diagrams of local nozzle loads for nozzles in the wall of tank. And here is a frame roof. So we have a special editor of tank frame roofs where you can define a quite complex construction of structural elements. And in current version, we cannot calculate this frame roof, but we have a special feature to prepare a model and export it in ANSYS using APDL language. And in next version, we will have some analysis features for these frame roofs as well. What is also added in the latest version is a jacket calculation according ISME A division 2, because we have this jacket modeling and calculation according other codes, but for ISME division 2, it was added in this version. Here is all stabilities, all opportunities you can have, all capabilities. And including conical jacket with closure. And another very interesting and important feature is cyclic loading. For cyclic loading in ISME, we mostly follow their recommendation and do it in past nozzle FAM in the places of concentration. But European code also have some formula applied, some simplified method for assessment of fatigue life. And now in version 3.8, it is available also in Parsec Web. And here is an example for this calculation. We can define the fatigue as a number of cycles in operating of the soil. And here is the calculation. Okay, now about the reports. You already see the reports, but the idea is the reports to be as detailed as possible and as structured as possible. So you can see this content data of the reports, and you see everything that you have in this report, including general data, summary tables, loading tables and diagrams, and trio of elements, and for each elements you can have detailed report with all cases, load cases, with all equations and the values of variables in these equations. And this is in HTML format, and then it can be exported to RTF format and open and printed in the Word, MS Word. And with this report, you can go to your authorized body to give them this report, and they can check if they want everything on your calculations. Another example of reports. This is for flat cover with some diagrams, equations, and some examples of real models from our customers. This is complex models of pressure vessels. And this is some models of heat exchangers, including double heat exchanger connected with several links with additional loads. And some examples with columns with different type of support structures, platforms, and big columns with several shells, cylindrical, conical. And several words about what is coming. Two new versions are coming, new version of Pass Equip and new version of Pass Nozzle FM. We are working on it just now, and some new features are already done in testing. And what we are going to add in new version, we are going to add API 620 for tanks, and for API 650, we will add the presentation of the same calculations using imperial equations, because sometimes there is a small difference in metric and imperial equations, but some of our customers prefer to have it put in the report in the imperial equation. And for tank frame roof, we are hoping to have stress analysis, not buckling maybe yet, but stress analysis inside our problem. We will add a seismic analysis of underground vessels. We're also going to add flat heads with beam support structure, like on this picture. And we will add special analysis, more precise, according to this AN standard, 1591, for flange strength and leak tightness. And some other also flange improvement like flange boss analysis and so on, and many other improvements. And for pass nozzle FM, after the version which is actual now, where you can do several connections to shell with several nozzles and several beam elements and the influence to each other. We're going also to have FEM analysis of shell support joints, including different types of supports like saddle supports and lugs, legs, and so on. Well, some examples are on this picture. Okay, this end of my presentation. And now I invite Andrei Krasnokutsky to show you some demonstration of capabilities of the software. Andrei?
Dear colleagues, I will show you two examples to illustrate the capabilities of the PASEQ program. The first is a vessel with a conical head and a jacket. Except for the calculation of the jacket according to ASME 8 Division 2, we will consider the features of calculating the nozzle for cycle strength according to EN 13445. The second example is the calculation of the dual heat exchanger. Let's start with the vessel with the jacket. To set cycling loading, it's necessary to activate in the general data and set the number of loading cycles. Next, in the nozzle editor, we set the cycle loading conditions and perform the calculation. The calculation results show that the allowable number of the loading cycles was 1.4 to 10 to the 5th degree. It's where high cycles and our cycle strength is available. In today's webinar, I want to show you an example of calculating a dual heat exchanger. When creating a model, first of all, it's necessary to specify general data on the working fluid and loading conditions. In our case, we will consider heating the oil in the tube sheet exchanger with an internally sealed floating tube sheet. We will set the oil density to 800 kilograms per cubic meter with full filling. In the future, this data will be taken into account when calculating the weight of the heat exchanger and the hydrostatic pressure on its element. The data for the tube space will be set in the heat exchanger itself. Here you can see the already created model of the heat exchanger. At the first stage, a lower heat exchanger was created. Here, in addition to geometry, materials, corrosion, etc., the conditions in the pipe space are set. In our case, it's water with design temperature 100 centigrade. To create a tube sheet, you can use the editor, which allows you to make a tube sheet of almost any configuration with up to 8 streams. After creating the lower heat exchanger, we create a new coordinate system with an offset relative to the base one. By copying the elements, we build the upper heat exchanger relative to the new coordinate system. Next, through the links, we connect the upper and lower heat exchanger into a single unit. In our case, these are 4 beams with U-shape. In addition, we connect the oil inlet and outlet nozzles. Through the semi-transparent mode, we can see the internal elements, such as the tube bundle, buffets, pins, and other. We can also check which materials we used for certain elements. And finally, we can calculate our heat exchanger. The calculation results show that the strength and stability conditions for all elements are met, including the oil inlet and outlet nozzles, where the loads were determined automatically. Here you can see the calculation of the loads according to the WRC 537, formerly 107. But I would like to draw your attention to the fact that the calculations have been performed as usually in case for vessel without taking into account temperature deformations. And in our case, this can lead to the significant errors, since the cooler connections of the beam restrain the temperature deformations of the hot oil nozzles. To check this, you need to go back to the general data and activate the function of the temperature strain and perform the recalculation. As a result of the calculation, taking into account the tightness of the temperature deformations, we see that the strength conditions of the nozzles and supports are not met. The main reason is the high radial loads in the oil nozzles, transmitted to the supports. For example, the radial force in the oil nozzles reaches more than 53 kN, or about 5.3 tons, and condition of strength felt as for shell and as for nozzles. We can look at a qualitative picture of deformations on the beam finite element model of our heat exchanger, through which loads are transmitted. But it must have in mind that loads are considered in the beam model without taking into account the so-called shelf flexibility, accounting for which can clarify the load on the nozzle. To determine the shelf flexibility, which we will take into account later in the calculation, we use the nozzle fan program, which can be run directly from PASECube. In the nozzle fan program, we refine some parameters, such as mesh quality, for example, to activate the calculation of stiffness and flexibility. At the same time, we exclude beam stiffness, which is already taken into account in the PASECube. In base element, we see lengths between support and flanges. The characteristics and the loads on the nozzle are the same as in a PASECube. And after that, we do the calculation. As we can see, the finite element calculation also confirms that the strength conditions are not met, not only by WRC, design by rules, but also by the finite element method, design by analysis. But in this case, we are interested in the flexibility of the nozzle to account for in the parser cube. We must transfer the stiffness values obtained during the calculation to the connection between the nozzles. At the same time, it is necessary to take into account the dimensions, the directions, and the values should be doubled, since the nozzles stand symmetrically on the both sides. In the next step, we must take into account the obtained flexibility in the PassEQ program. To do this, we insert the flexibility obtained in the pass nozzle fan into the connection between the nozzles. And the same in the second link. After that, we calculate taking into account the flexibility between nozzles. As we can see, the strength conditions are not met in the two lower nozzles. At the same time, the loads in them decreased significantly, from 53 kilonewtons to 19 kilonewtons. And the strength conditions is not fulfilled quite a bit. Since WRC is considered a conservative method, it is recommended to use the finite element method for a final conclusion. To do this, as in the previous case, we transfer the nozzle to the pass nozzle fan program and calculate it here. Compared to the previous case, only the nozzle loads have changed. And the calculation under which show the achievement of strength conditions with a good safety factor of 1.7. In conclusion, I would like to say that the PassEQ program has a wide range of features, including the calculation of 2, 3, or more shell and tube heat exchangers connected together. In this case, additional loads caused by tightness of temperature deformations can be taken into account. These loads often cause very high stresses in the tying nozzles and supports. To reduce them, it's advisable to take into account additional flexibility. The flexibility calculation can be performed by the pass nozzle fan program, which can be called directly from PassEQ. If the strength condition of the nozzle according to on WRC are not met, it is recommended to use a more accurate calculation, designed by análisis, for the final conclusion. Thank you for your attention.
Thank you, Andrei. Okay, it's now time for questions and answers. And we have several questions, but before this, I'll just show the slide with our email and coordinates. You can go there and check yourself for opportunities, request for trial version of the software, and so on. Okay, but I don't see any questions at the moment. Do we have questions? Okay. In fact, I don't see any questions. So let's wait several seconds if anybody wants to ask anything. Meanwhile, I would like to thank Andrei. I think it's a really very interesting and informative demonstration with some aspects which is even for me are new. Okay, we don't have questions, but please send us any questions via email. We are happy to any your questions and your proposals or ideas how to improve our software. And yes, if you have questions, please write them to question and answer section. No? And also you can send to a corporate WhatsApp account your questions. Okay, I don't see any questions at the moment. Then with that, let's finish our webinar. And thank you. Thank you, Andrei, and all team, and the participants. Thank you for coming. And we are waiting for your message. Have a nice day.